Hey, welcome back to Science, and this is our third installment in the home heating series. This time we're looking at how can you trap that thermal energy in your house. Remember, when your furnace is on, you are burning money. Burning fuel, but it costs money. So if we can trap the thermal energy in, then our furnace, our boiler does not need to be on as much, therefore you're saving money. So, quick review here. Something called a thermal insulator is something that allows very little thermal energy flow, while a thermal conductor is something that allows that thermal energy to flow easily. Yes, electrical insulators and electrical conductors, very similar terminology. Often, if something is a thermal insulator, it is an electrical insulator. Often, if it is a thermal conductor, it is a electrical conductor. There are a few exceptions, but these are very commonly true. Okay, so let's take a look at this. One of the things that we would have done in class that we never really got to, things that are typically insulators often have a really common trait about the material. They often have trapped air pockets. Trapped air pockets end up being great as thermal insulators. And if you think about it, that fits, because one of the things you do in the winter time is wear multiple layers. Those multiple layers are helping to have pockets of trapped air to trap your own thermal energy. You are a little miniature furnace kicking out thermal energy. A blanket, a sweater, those things help trap that thermal energy near you. If you put on too many layers and there's not actually air pockets in between, you actually defeat the purpose and you can get cold by putting on too many layers because you don't have those air pockets in between. Okay, so there's something called Rvalue. Insulation is measured in an Rvalue. You may have seen that on foam insulation from time to time. You may have seen it on fiberglass insulation if you ever have had the fun of installing that. In our area, well, throughout the world, there's something called Energy Star. You may have seen it when you're buying electrical appliances. Energy Star values for insulation. Basically what these are doing is they're saying, hey, this is the sweet spot. If you put in this much insulation, it will pay itself off. Not as much insulation as this, you're going to spend a whole lot more in energy costs and heating costs. More than this, the gains that you have from putting in that extra insulation will not pay off the cost of that extra insulation. So Energy Star is kind of a nice value to go with to hit that sweet spot. Around here, they suggest 21 R21 for walls, R49 for ceilings, R18 even in the floor, and then basement walls they're saying should be even insulated around R15 to R19. Some of these, by the way, do have local codes, usually lower than this, almost always lower than this. These are the recommendations if you want to hit that bang for your buck sweet spot. Now, I look at this and I say, gosh, why is that ceiling such a high number? Oh, I hope you know this thing. Please tell me that you can pause the video, discuss it. Why does the ceiling have such a high R value? Because warm air rises. Please don't say that heat rises. Heat travels from higher temperatures to lower temperatures. Warm air rises and is trapped up near that ceiling and has a tendency to go through the ceiling if it's not insulated as well. Okay, I'm going to walk us through the basics of building a house. This is called a stick-built house. Right here we're seeing just the frame, just the sticks, if you will. The next thing to do is to put on the wood siding, so an exterior wood siding, not the final siding. And then you end up with these cavities here. In those cavities, that's where the insulation will ultimately go. Usually first you're going to put in all the electrical and all the plumbing that needs to be in the outside walls, if there's any that needs to be in there. And then you put in the insulation. Now this is still missing the inside wall, a dry wall or whatever your inside wall is. But this is what the inside of a house typically would look like before the inside walls are put up. Insulation to stop thermal energy transfer. Now if we were to take a cross section of that wall, you're saying, hey, how does that R value get its place? Well, this is the inside of the house, this is the outside of the house. You might have some siding. This one says aluminum siding, it might be fiberglass. You've got your inside wall. Now there's those studs, those sticks. If it was built using a 2x4, you would have a 9 centimeter gap to put in insulation. Going at that, the way that you might solve that is fill in a chart like this. What you do is you look at, for each material, what the material is, what the R value is for every centimeter or for every inch. Drywall has a 0.35 R value for every centimeter, and the drywall is only 1.5 centimeters. So that gives us an R value of about 0.5. The purpose of drywall is not actually to insulate. The fiberglass is where that's going to be coming from. But we do want to include the wood and the siding. Filling this table out, it might look something like this. You'll notice most of that insulation, 11 R value, is coming from the fiberglass. The aluminum, you're saying, well gosh, what's the point of having siding on it? Aluminum siding or vinyl siding, it's not insulating. You're right, it's not insulating. The vinyl siding, the aluminum siding, the outside siding, that is to keep the elements out. The water, the rain, the snow, that's for keeping that out, not really for insulating. Now if I add all of these up, we've got a problem. Because they only add up to not even 13. Is that good enough around here? The answer is no, it's not. But around here, we don't usually build houses with 2x4s. Instead, we use 2x6s. So it jumps this gap like that. Changes it from a 9 centimeter gap to a 14 centimeter gap. When you use that, you now end up with a total R value of almost 19. Certainly better, and certainly it meets code. It's not quite to that R value standard. A great question is, well, what could you do to get a little bit further? Well, the wrong answer is to say, well, just shove a little bit more insulation in there. Ask yourself, why would trying to shove more insulation into that gap not work? If you're saying, hey, that's going to take out those air pockets, you're absolutely right. That's like trying to put on 5 jackets and them being so tight that you have no air pockets and you get cold. You don't shove more insulation into this area. You get the proper amount for the area. You have several options. You can put on, outside of this wood siding, you could put on a layer of foam board. You might call it styrofoam, but it's polystyrene. You might put on that. Typical of that is 5, R value of 5. So that'd be a quick way to jump this value up to almost 24. Asked and answered. So a great question too is, what are the benefits of building with plenty of insulation, with the proper insulation? Yes, I feel like I'm flogging a passed away equine here, it will save you money in heating costs. You're saving money. The drawback is it costs a lot of money up front. When you build or when you redo the house, it could cost a lot of money to pay for that better insulation. But it will pay itself off. Insulation does not usually need to be maintained. Once it's there, it's generally there, unless something goes wrong. And it's always going to be working for you. Houses generally are long-term investments. And you might be saying, yeah, but I'm going to plan on selling my house right away. I know when I buy a house, I want to know what the bills are to know if I'm going to have to pay a lot. You're supposed to supply your heating bills and electrical bills when you sell a house so that potential customers can see how much it will cost for their monthly bills. Selling a house that is well insulated will have more value than a house that is very poorly insulated. So it comes down to money. It comes down to saving money. A lot of different types of insulation. You can have what's called blown-in insulation. This is some really nice, neat stuff. Some cellulose, I think this one is. Or you have the traditional fiberglass. You'll notice that this guy in particular has on long sleeves, gloves, even a respirator or a face mask. Hopefully you have access to a face mask nowadays. If you put in insulation yourself, it's pretty easy to do. If you decide to add some more to your attic, it's easy to add to an attic, and you buy fiberglass insulation, even if it's summertime, you really need to have long sleeves, a face mask, even eye protection on. Because fiberglass, if you take a look at the name, it sort of makes sense. It's fibers of tiny, tiny little shards of glass. If you've ever used this and you said, man, I'm really itchy, yeah, because a lot of little itchy glass particles got under your skin. Worse yet would be breathing in some of those little itchy particles of glass and getting them caught in your lungs. Not a cool thing. So if you do use this, please take the proper precautions. It's easy to work with. You don't need to hire a professional, but you do need to be safe. Again, a guy adding to his ceiling. I did this in a previous house. I had gone up and checked. I noticed that my heating bills were a little bit high, and I was also getting some ice dams. More on that in a little bit. I bought some cheap insulation, inexpensive insulation. Cost me maybe $400. Okay, that's a fair amount, but I made that up in heating costs within 2 years. Nice. Plus, I no longer had problems with ice dams. Very nice. Sometimes it'll look like this from the inside of the house. Paper on one side. So there are these really cool toys called infrared cameras. I got to play with one once. Really kind of fun. FLIR camera. I don't know about you, but I had a dog growing up where he was not allowed to be on the furniture. If we were all gone, we'd come home, and it was really strange. The rocking chair would always be rocking, and the dog would be on the floor looking very innocent. This guy with his FLIR camera totally busted his dog. That doggy was sitting here just a few minutes ago. Busted. Now, besides just doing that, there are much more practical reasons to use these. You know what? We're going to make this 2 days. We're going to cut this one off here. So this will be 1 days. I'll continue this in a second video. So part 2 will be tomorrow. be ready to learn some cool things on part 2. Till then, take care.